It's a probability question 10.2 from the 2022 paper 1, the national paper this year. Gee, this is my second try at it. I did do this first part all right, but I didn't read the next part really so carefully. It was kind of tricky and a little bit strange. But let's just do the first one. A 4-digit code is required to open a combination lock. The code must be even numbered. And they meant to say, but it would have been a little clearer, that it ends in an even digit. So that's the restriction. It ends in an even digit. You can't use the digits 0 to 1. Well, that leaves you with 2, 3, 4, 5, 6, 7, 8, 9. 8 digits. But it must end in a 2, 4, 6, or 8. Okay, now the way you do, it's a 4-numbered code. So what you do is you put boxes. Now at the end you've got 4 choices. 4 choices there, so put a number 4 there. But once you choose one of the even numbers, then you've only got 7 numbers left. And then you have 6, and then you have 5, and that's why your answer is the product of 7 times 6 times 5 times 4, because it's the product of those choices. And it's equal to 840. 840 possible codes. Okay, the next question. It says calculate the probability that you'll open the lock at the first attempt if it's given that the code is greater than 5,000 and the third digit is 2. Now, it's still a 4-digit code, so there's 4 boxes here. Now, it says here that the third digit has to be a 2. Well, I'm looking at it, this is the way I did it. I'm looking at it in terms of choices this way, starting with either a 5, 7, or 9. The first time it said greater than 5, so I thought, oh, I won't use 6. Oh, it should start with 6, but silly mutt. If it's got a 5 in front, it's going to be greater than 5,000. So right here, starting with the 5, 7, or 9, there's 3 choices. And because you've used one even number, you've used the, let's do it this way. You're locked into one choice for choosing the 2, which leaves you with 3 more even numbers. Well, that means chose 2 numbers, then you choose a number here, either a 5 or a 7 or 9. That's 3 choices. Well, you've used 3 of these numbers, so you've got 5 choices left. Now, that's the easiest way for me. 3 times 5 times 1 times 3. 45 ways to have, starting with a 5, 7, or 9, and ending in an even number. But what if you start with a 6 or an 8? Well, then you don't have so many choices. You still started with a 2, so that took out one of the even numbers. You start with a 6 or an 8, then you don't have any more. Then you only have 2 even numbers left. That's why I put a 2 there. But if I started with a 2, started with one of these, and then started with another even number, I've got 5 numbers left. That's 2 times 5 times 1 times 2. That's 20 ways you can make these conditions happen, starting with a 6 and an 8. Okay, the total number of combinations is 65. And so your answer is, if you know that there's these 65 different codes, what's the probability that you'll open up the lock on the first attempt? Well, you've got 1 chance in 65. There's 65 things. Now, I didn't read it like that the first time, and the wording and the reading, some of these things are a little bit, the way they've done every other probability question in the past, they use these number of choices right here, this 840, and then you work out a more restricted situation, and you make a fraction out of that with your probability. So I went and answered a slightly different question, and that's why I got it wrong. So take a look at this. The first time I did it, I was thinking, what's the probability you'll open the lock in the first attempt, given that using the total possibilities in 10.2.1. I've read it closely now. I realize you're not supposed to do that. So I put my 65 over 840 to get that. That's just not right. You don't do it that way. Okay. And there's some other people from the answer series. They did it kind of differently. They said, what are all the ways it can happen with a 4? Look, they had one choice. They have the choices up here just the same way. Look, they got the same 65, but it's a little bit confusing. You could stop the video and take a look at what they've done. But they've got 65 choices, and the probability of opening up the lock, if you try one of those, is 1 chance in 65. And I think their solution makes sense here. We both got 65 the same way going through the reasoning here. You see, if it ends in a 4, then you've got 5 digits greater to play with here. If it ends in a 4, 5 digits to play with. And then you'll only have 5 digits left after you've used these 3. And so it's 5 times 5 times 1. That's if it ends in a 4. If it ends in a 6, you can't use that 6, so there's only 4 choices here. And then 5 and 1 times 1. One way to have an 8, 4 times 5. Look, we get exactly the same thing, but they laid out the possibilities a little bit differently here. So there are other ways to do it. So I hope, now I'm pretty sure we got it right this time. Well, the people from the Answer series got it right. But the wording of some of these questions was a little bit challenging in the style. There was little twists and turns and, ooh, not so nice.